Hi everyone, and welcome back to this series of short videos devoted to CytoPipeline, an R package for building and visualizing pre-processing pipelines for flow cytometry data. In this last video of the series, we're going to briefly touch upon a few advanced settings of the execute function that can be used to fine-tune the running of the different pipelines. Let's get started. In order to demonstrate the use of the first setting, which relates to the management of the cache on the disk, let's reuse a previously run pipeline, which is the pipeline with Flow AI that I demonstrated in the previous video. And so let's recreate the CytoPipeline object using the corresponding JSON file as input. Let's do this and then plot the CytoPipeline processing queue. Indeed, so everything is in green, meaning that we have indeed stored results corresponding to this pipeline. Now, let's imagine that we would like to rerun the same pipeline, but slightly amend it. For example, changing one parameter of one step of this pipeline. And so let's go to the JSON file and slightly amend, for example, this remove debris step and put, for example, the level to 0.97. Let's save the JSON file and recreate the CytoPipeline object to take our changes into account. Now, if I plot again the CytoPipeline processing queue, I receive this warning message, and this is a phenomenon I described in a previous video, in that the program has identified that the CytoPipeline object that I want to run has a specific experiment name, and under that experiment name, there are already stored results of which the parameters are not exactly the same as the one that are used in our CytoPipeline object. And this is also highlighted by those red bubbles on the right hand side. So now if I want to execute the CytoPipeline object as is, actually I can't do it because there is this inconsistency. So what we will need to do is to delete the cache corresponding to this experiment name, and we could do it using so basically manually delete the cache, so by doing this, so looking at the directory which contains the experiment that we are interested in, so it's BBT demo flow AI, and manually deleting the directory .cache. This is one possibility. But what we would like to do is do it a bit more elegantly, programmatically. So when we run the execute function, in fact, there is an additional parameter which is here hidden, but as a default value, so rmcache equals. So by default, this is false, but if we set it to true, basically, we tell the execution function to start removing the cache before running the different steps. And so if we do that here, and we run the statement, now we have the possibility to run the pipeline. And so this is going to trigger all the steps again on the different sample files. This is going to take a few seconds, but it is rather quick, I can see. Yes, so we are almost done. Okay, and so everything has run correctly. Only there is this warning message, which is a normal warning message saying that it found a previous cache with the same experiment name, and so it removed it. Okay, now if I plot again the CytoPipeline processing queue, I get everything in green. So I have stored everything. So that was it for the first setting I wanted to show. The second one relates to the execution of the pipeline in parallel. Indeed, not for the scale transformation, but for the pre-processing of the files, this boils down to running one step after the other and independently for each different sample file. So we could do it in parallel, so running one sample file on, let's say, on different cores. This can be done using the BioC parallel package of Bioconductor. And so those who are familiar with BioC parallel will recognize some of the parameters that are used to tune the BioC parallel infrastructure. So in BioC parallel, we need to create a backbone which allows running the task in parallel. And this is done here, creating this BP variable and using the snow param backbone. This is one of the different backbones that are possible in BioC parallel, and typically, basically, is a generic one that can also be used under Windows. Let's note that I used the progress bar equal true parameter in order to be able to visualize what is that indeed we are creating this no param and see the processes running. Okay, so this is one of the parameters that is added to the execute function, and this is used in conjunction with the use BioC parallel flag equals to true. There is one additional parameter that is important to know, is the BP options that will be used, in fact, to know to set what packages are needed in order to run the different steps of the pipeline. So let's assume that in the pipeline you have created a step which needs your package, let's say your package named my package. So then in that case, in this array under package, we also need to add my package as an additional package to know all the packages that need to be loaded in the different cores, let's say. So let's try to execute this. And so as I use remove cache equals true, we will run again all the pipeline. And so now after running the scale transformation part, it goes to the file pre-processing of the files, and here we can see this famous progress bar showing that we are now in the BioC parallel environment. So we will have to wait a little bit that this process ends up. We have 50% run, so we have two cores here because we have two different sample files, and so this has been done, and we have the same warning message on the previously cached with experiment name. We moved it. Of course, here we only have two sample files, so it's not very useful to use this parallel setup. But in the cases where we have tens or hundreds of different FCS files to pre-process, it can become very, very handy. And that's it. In this video, we've shown a few technical settings that can be used to fine-tune the run of our pipelines. With this short video, we end up here our series on CytoPipeline. I hope that you've enjoyed it. Thanks for watching and see you soon.